When dealing with fractions, specifically rational functions, we know that we can add two fractions by simply getting a common denominator. So for example, 1 over x minus 1 plus 1 over 2x plus 1. We could get a common denominator here, and I'm not going to bore you with the details there. You'd end up with this 3x over 2x squared minus x minus 1. Now this form here, where it's combined, is very useful if you're trying to, say, graph the function. However, there are several applications where this broken up form is actually more useful. So the question is, we know how to get from the separated form to the combined form, but do we know how to get back to the, we'll call it the decomposed form, okay? And this process of going from a single fraction to smaller fractions, which we'll call partial fractions, is called partial fraction decomposition. Okay, so it's where we take a single rational function and write it as a sum of fractions with simpler denominators. This process we can do by following this process, which is quite involved actually. So you'll want to probably just have this this list somewhere where you can easily access it, because the process is pretty involved and depends on the type of rational function that you have, specifically the denominator and the factored form of it. So you factor the denominator completely, and then the partial fraction decomposition form depends on if the factors are linear or irreducible quadratics, and what the exponent on each of those factors is, okay? And then you go through and you're going to solve for some unknown constants. So this is best seen by just looking at lots of different examples. So let's look at an example. We want to find the partial fraction decomposition of this rational function. The very first thing we need to do is factor our denominator completely. So we're going to factor by grouping. Okay, we've got these two groups. Out of the first, we can factor an x squared, and we're left with an x plus 2. And out of the second group, we can pull out a negative 1, and we're left with an x plus 2. So you can pull the x plus 2 out, and you are left with an x squared minus 1. And then x squared minus 1 is a difference of squares, and so that factors as x minus 1 times x plus 1. So there's our factor to denominator. Let's go ahead and put it here in the denominator. So this is your very first step. I'm going to go ahead and move this down. This is the very first step in doing a partial fraction decomposition. The next thing is we're going to actually write out some partial fractions, okay? And this is where the factors come into play. Each of these factors is a linear factor, okay? So what we're going to do is we're going to get a fraction with each one of those. So x plus 2, x minus 1, and x plus 1, okay? The numerators we don't know, okay? And so we're just going to call those just some random constants that we don't know, but we'll just illustrate them with some variables there. And those constants are what we want to find. So our partial fraction decomposition form is we have a fraction for each of the factors, and we have in the numerator an unknown constant. Okay. The next thing we're going to do is we're going to multiply both sides of this equation by this denominator. Okay, and when we do that, let me go ahead and move this over so we can see that happen. Okay, we multiply by the x plus 2 times x minus 1 times x plus 1. And then same thing over here. X plus 2 times x minus 1 times x plus 1. On the left side of the equation here, this just entire denominator cancels out completely. This is gone, and we just are left with 5x plus 7. Okay. On the right side, we have to take each of these fractions and multiply it by that whole thing. So if I take a over x plus 2 and multiply by all of this, you'll notice that the x plus 2 cancels, and we're left with a times the other two factors. So x minus 1 and x plus 1. With b over x minus 1, the same type of thing happens. The factor of x minus 1 will cancel, and we're left with these other two factors. So x plus 2 times x plus 1. And finally, for the third fraction, the x plus 1 will cancel, and we're left with the x plus 2 and the x minus 1. Okay, so after we've multiplied by that denominator, you should be rid of all the fractions. The next thing we want to do is we want to solve for a, b, and c. So the easiest thing to do is to plug in some values of x that will cancel out some of these factors. And the easiest values of x are going to be the zeros of that original denominator. So, oh, I don't know how this became a 2. That should have been a 1. X equals -2 is a 0. And so if I plug that into this entire thing, okay, here I get a -10 plus 7, which is -3. And on the right side, I have anything that has an x plus 2 disappears. So the whole b term and the whole c term are gone. And we're left with a times a -3 times a -1. That's just, again, plugging x equals -2 into each of these. So that leaves us with -3 equals 3a. Okay? In other words, divide both sides by 3 and you get a equals -1. And we can do the same thing with the other zeros of that original denominator. If you plug in x equals 1, you get 5 times 1 plus 7, that's 12, equals, and now every factor that has, or every term that has a factor of x minus 1 will cancel out. So now the a term and the c term disappear, and we're left with b times 1 plus 3, 1 plus 2 is 3, and 1 plus 1 is 2. So we have 12 equals 6b. Divide both sides by 6, and we get b is equal to 2. And then we can do our last zero of that original denominator, which is -1. 5 times -1 plus 7 is 2. And now every term that has a factor of x plus 1 will disappear. So the a term and the b term are gone because, of course, if you plug -1 in, you get a 0 right there. And a times 0 is 0. Okay, so these are all 0. We're left with our c term, which is c times -1 plus 2 is 1, and -1 minus 1 is -2. So now we have 2 equals -2c. Divide both sides by -2, and you get c equals -1. So now we know our a, b, and c. We're ready to plug those in, and we have our partial fraction decomposition. So our original function, our original rational function, with I'll write it in the factored form, is equal to a over x plus 2 plus b over x minus 1 plus c over x plus 1. And that is the partial fraction decomposition of this rational function.